In this lecture here, we're going to begin our study of polynomials. Now, this is a term you're going to hear a lot throughout this course, and we're going to spend a significant amount of time over this course talking about polynomial functions, operations on polynomials, graphing polynomial functions. So it's incredibly important that in this lecture here, we understand exactly what a polynomial is and how to perform basic operations on polynomials. So this lecture here, what we're going to do is we're going to understand the vocabulary of polynomials. Then we're going to start talking about some simple operations on polynomials. We'll talk about how you add and subtract polynomials, how you multiply polynomials. Dividing polynomials is a little bit tricky, and we'll deal with that in a different lecture. We'll talk about how you use FOIL in polynomial multiplication, and we'll talk about using special products in polynomial multiplication. And then finally, the last thing we'll do is we'll talk about how you perform operations with polynomials and several variables. Okay, so first let's talk about some vocabulary. So a polynomial in x, and now what this x represents is this is just our variable. Okay, is an algebraic expression of the form, and this actually looks a lot more complex than it is. Okay, so a with the subscripted n times x to the n. So n here, this is the exponent, and our variable x here is the base, okay? Plus a sub n minus 1 times x to the n minus 1. So notice how you're taking the exponent and you're subtracting 1, and then you're going to keep going. So a to the n minus 2 times x to the n minus 2 power plus all the way down to a to the 1 times x, this is really to the 1 power, plus a to the 0, and this you can think about it as x to the 0 power. Remember, anything to the 0 power is just 1, okay? All right, so where a sub n minus 1, a sub n minus 2, to a to 1, to a to 0 are real numbers. Think about these as coefficients, all right, of these individual terms. So these are just real numbers, okay? So there could be something like, let me give you an example. 5x cubed plus 3x squared minus 2x plus 7. Okay, this right here, these are my a sub n. So this case here would be a sub 3, a sub 2, a sub 1, a sub 0. All right, and then you can see here that I have x to the n. In this case, it's 3, and then minus 1 squared minus another 1, and so on. So we say the polynomial is of degree n. Okay, so the degree of a polynomial is the highest exponent. So in this case here, this polynomial expression here would be a degree 3 polynomial. All right, a sub n is the leading coefficient. So in this case here, the leading coefficient is 5. And the final, this a sub 0 here, this is just the constant term. So in this case, the 7 is the constant term. So this is really just a complex way of showing an algebraic expression. And you've all seen, algebraic expressions of this form. Now we just know that this is what's considered a polynomial. So this is how we'll always call them. We'll say, okay, this polynomial expression here. Now, when a polynomial is in standard form, the terms are written in order of descending powers, all right, of the variable. So for example, this is in standard form because it starts with the cube, then goes to the square, and then the x, and then the constant term. All right, thus the notation that we use to describe a polynomial in x is the same notation here. All right, it's also from the previous slide. All right, and simplified polynomials with 1, 2, or 3 terms have special names. So a monomial, okay, just has one term. So I'll write it up here, an example. A monomial would be something like this, just 5x to the 7th power, or 2x, or 12 to the x to the 100 power. Okay, this would be an example of a monomial. A binomial has 2 terms. Binomial could be something like this, 3x squared plus 7x, or it could even be something like 5x plus 2. It has 2 terms in it. Okay, and then finally a trinomial. Obviously the tri means it's got 3 terms. So it might be something like this. 2x squared plus 3x minus 8. All right, or even something like this. 7x to the 15th power plus 72x minus 9. Something like this. This is also be a trinomial. All right, finally, simplified polynomials with 4 or more terms, they don't have any special names. So whenever I say, that, a monomial, a binomial, a trinomial, we understand what those are. It's something that has 4 terms, I'll just say this is a 4-term polynomial. All right, same with 5 or 6 terms and so on. All right, now we want to talk about some simple operations on polynomials. All right, so polynomials are added and subtracted by combining like terms. So we've actually covered this before as well in a previous lecture, but like terms are terms that have exactly the same variable factors. So something like this. 5x squared and 7x squared. They're like terms because they each have an x squared in it. All right. These are not like terms. Let me show you. Okay, something that has this. Minus 12x cubed and 4x to the 5th power. They're not like terms because they don't have the same variable raised to the same power. Okay, so like terms, something that has x squared, or even something like this would also be like terms. Minus 15x to the 7th power and 72x to the 7th power. As long as the variable and the exponent are the same, like terms. Okay, so what we can do then is we can add and subtract the coefficients of these like terms to combine them. All right, so let's do an example of adding and subtracting here. All right, so here would be the first example. Let's add the following. All right, let's take 12x cubed plus 8x squared plus 7x plus 2, and let's add to it 8x cubed plus 2x squared minus 3x minus 15. All right, so all you're going to do this is let's just put the like terms next to each other. So we're going to have 12x cubed, and then look over here, 8x cubed, that's its like term, plus this 8x squared, and then over here plus 2x squared, and then 7x minus 3x, and then plus 2, and then minus 15. So now just start combining the coefficients of the like terms. So 12 and 8 gets me 20x cubed. 8 and 2 gets me plus 10x squared. 7 minus 3 gets me minus 4x. And then 2 minus 15, well, that's minus 13. So what I've done here now is I've just added these 2 separate polynomial expressions. All right, let's do another one. This time we'll do subtraction. All right, so let's subtract the following. So let's take 2x squared minus 8x plus 7, and let's subtract away 4x squared minus 12x plus 5. Okay, so the first thing I would recommend with subtraction is, look, this negative, the subtraction sign is in front of the parentheses. So let's distribute it first. So I'm going to leave this first polynomial the same. And look, now I'm going to distribute. So negative here, this becomes minus 4x squared. Negative, negative, that's why I did this, becomes plus 12x. And then negative, positive becomes minus 5. So now let's just rearrange the terms, right? So I've got 2x squared minus 4x squared. And then I have minus 8x plus 12x, and then plus 7, and then minus 5. So then look, 2x squared minus 4x squared, that gets me minus 2x squared. Minus 8x plus 12x, well, minus 8 plus 12 gets me plus 4x. And then just 7 minus 5, well, what does that get us? That just gets us 2. So all this adding and subtracting these polynomials, it's all about combining like terms. And so we've done this, excuse me, we've done this before. So this is really just about putting the terminology to it. So now I've just been doing it. I know that these expressions are now polynomials. Okay, now let's talk about multiplying. So the product of two monomials is obtained by using the properties of exponents. Okay, so we know all the properties of exponents, so we can review these in a previous lecture. So review if needed. All right, but we can use the distributive property to multiply a monomial and a polynomial that is not a monomial. Okay, so I'm going to do some examples where you'll see me use the distributive property. Okay, so to multiply two polynomials when either is a monomial, we multiply each term by one polynomial by each term of the other polynomial. I'll do an example so you'll see this, and then we combine like terms if needed, if we have to. All right, so let's do some examples. So we'll start by multiplying a monomial by a trinomial. So let's take, all right, so here would be the example. Multiply the following. So let's take 2x cubed and let's multiply it by 5x squared plus 7x minus 4. And here's what you're going to do to distribute this. You're going to use the distributive property. So you're going to take 2x cubed and multiply it by 5x squared. Then you're going to add. You're going to take this 2x cubed and multiply it by this 7x. And then you're going to subtract 2x cubed by the 4. All right, so now just simplify. 2 times 5 gets me 10. And now x cubed times x squared, well, when you multiply, you add the exponents. So this becomes x to the 5th. Plus 2 times 7 gets me 14. X cubed times x, well, now I have x to the 4th. Minus, well, just 2 times 4 here gets me 8, and then I have that x cubed. Wonderful. All right, now let's step it up. Let's do a little bit of a trickier one. Let's multiply a binomial, so that's a 2-term polynomial, by a trinomial, which is a 3-term polynomial. All right, so multiply the following. All right, so let's take 2x plus 1, or let's do 2x plus 3. All right, so that's a 2-termer. So a binomial, so by a trinomial. So let's do 3x squared plus 5x minus 2. All right, so here's how I'm going to do this distributive property. I'm going to take this whole binomial, and I'm going to distribute it here. So you're going to have this 3x squared, and you're going to have to multiply it by this 2x plus 3. Plus, now I have this 5x, and I'm going to distribute this all the way over here. So I'm going to have to multiply there. And now finally I have this minus 2, and then I'm going to distribute this 2x plus 3. So now what do you have to do to simplify this? Now distribute again. So I have 3x squared times 2x. Well, that's going to get me 6x cubed, right? Because 3 times 2 gets me 6. X squared times x gets me x cubed. 3x squared times 3. Excuse me. Well, 3 times 3 gets me plus 9x squared. Now here, 5x times 2x. Well, that gets me 10x squared. 5x times 3. Well, that gets me 15x. Now minus 2. Now don't forget this negative with it, okay? So minus 2 times 2 gets me minus 4x, because I have that x there. And then whoop, minus 2 times 3 gets me minus 6. Now combine like terms. All right, so there's nothing with the cubic, so this 6x cubed stays here. Now look, 9x squared plus 10x squared, that gets me 19x squared. 15x minus 4x, well, that's 11x. And then don't forget you still have this minus 6 here. And just like that. The reason there's another way you could do this. You could distribute the 2x to each term and then distribute the 3 to each term. The reason I did it this way is because when you go to combine your like terms, notice how it lined up perfectly, like the x squareds were next to each other, the x's were next to each other. But you could do it the other way if you've seen it the other way. It's totally fine. You'll get the same answer in the end. All right, so now I want to talk about a special method, okay? So the product of two binomials, okay? So any two binomials can be quickly multiplied by using what's called the FOIL method. You might have also heard to it as first, outer, inner, last. So the F represents the product of the first two terms in the binomial. O represents the product of the outside terms. I represents the product of the inside terms. And L represents the product of the last or second term in each binomial. So FOIL is a quick little method for multiplying two binomials. And let me work you through an example to see FOIL in action here. All right, so let's multiply the following. Okay, so we'll do two examples on this slide here. So let's take x plus 3 and multiply it by x plus 2. Okay, so the F says take the first terms. Okay, so this would be the first term times the first term over there. X times x gets me x squared. O says the outer terms. Well, look, on the outside here I have this x times this 2. Well, x times 2 gets me plus 2x. Now the inner part, so it would be the inner part here, 3 times x gets me plus 3x. And then L stands for the last. So 3 times 2 gets me 6. And then what you've got to always remember to do is combine the middle terms here when you FOIL. So this is x squared, 2x plus 3x. That gets me 5x plus 6. Let's try this one. 2x squared minus 3 times 4x squared plus 1. All right, so FOIL, first terms. 2x squared times 4x squared, that gets me 8x. Well, x squared times x squared gets me 8x to the 4th. The outer, 2x squared times 1, well, that gets me plus 2x squared. Inner, minus 3 times 4x squared gets me minus 12x squared. And then last, minus 3 times 1 gets me minus 3. And then you just have to do 2x squared minus 12x squared. So this gets me 8x to the 4th minus 10x squared minus 3. So first, outer, inner, last is this FOIL method. All right, now let's talk about some special products. So there are several products that occur so frequently that it's convenient just to memorize the form or pattern of these formulas. So the first one here we have, so if A and B are real numbers, variables, or algebraic expressions, then here's what we have. If you have the product of the sum and difference of two terms, okay? So A plus B and then times A minus B. So this would be something like x plus 3 times x minus 3. Notice how the A here is x and the B here is 3. This will always just be equal to a squared, well, that would just be x squared, minus, well, my b was 3. 3 squared gets me 9. All right, then there's the square of a binomial. So if it's a plus b squared, well, that's equal to a squared plus 2ab plus b squared. A minus b, that expression squared, is equal to a squared minus 2ab plus b squared. All right, well, let's work some examples with these special products here. So let's multiply or find or evaluate these special products. So let's do this one. 2x minus 5 times 2x plus 5. Well, if you look here, look, the a's are the same, the b's are the same. I have a minus plus. Now, it doesn't matter here. If you look in the formula, I have plus, then a minus. It doesn't matter if it's the minus before the plus. That's okay. So this is my a. And my b here is the value 5. So I know this is going to be a squared minus b squared. So it's going to be 2x squared minus 5 squared. Well, 2x squared, 2 squared is 4, so this becomes 4x squared, and 5 squared gets me minus 25. Let's try this one here. Let's look at x plus 3 squared. All right, well, I know that whenever I see a plus b squared, this is going to be equal to a squared plus 2 times a times b plus b squared. So in this case, my a is x and my b is 3. So it's going to be x squared plus 2 times x times 3 plus 3 squared. Sorry, the squared should be over here. Well, x squared just gets me x squared. 2 times 3 times x gets me 6x. And 3 squared, that just gets me 9. And the more you see these formulas and the more you practice them, the easier they will be. The easier they will become. All right. Let's move on to kind of the last topic in this section here. All right, this is polynomials of several variables. A polynomial in two variables, x and y, contain the sum of one or more monomials in this form: a times x to the m times y to the m, x to the n times y to the m. So the constant in front of each term is the coefficient, and m represent whole numbers. Okay, so the degree of the monomial is a of the monomial a x to the n y to the m. You just add the exponents. So for example, if you have something that looks like this, 5x squared y to the 7th, the degree here of this polynomial, we would say this is a degree 2 plus 7. It would be a degree 9 polynomial. So the degree of a polynomial, two terms, is just the highest of all its terms. So if you were to look at, something like this, 5x squared y to the 7th plus 12x cubed y to the y squared plus 8xy. Well, the largest sum here, the sum here is 2 plus 7 is 9, 3 plus 2 is 5, 1 and 1 is 2. We would still say this is a degree 9. All right, polynomial in two variables. All right, adding and subtracting these, it's just like combining like terms. All right, so let's look at this one. Let's take 2x squared y to the 4th minus 8xy, and let's add to it 3x squared y to the 4th plus 2x squared y minus 7xy. All right, well, look here. You're going to have to combine like terms. So they need to have the same variables and exponents. So 2x squared y to the 4th, its like term is right over here. 2x squared y to the 4th plus 3x squared y to the 4th. Now look here. 2x squared y has no like term, so I'm just going to put this here. No other term that's a like term. Now minus 8xy, minus 7xy. Those are like terms because they have the same factors in them. Factor variables in this one. So in this case, you just add the exponents now. 2 plus 3 gets me 5x squared y to the 4th plus 2x squared y, and then minus 8 minus 7 gets me minus 15 x to the y. So you're just going to follow the same rules for that you did for adding or subtracting. In this case, I added. All right, but subtracting is still the same here, as you would with a single variable. All right, let's end by talking about multiplying polynomials in two variables. So here, you're going to multiply and follow the rules of exponents. All right, so let's take this. Let's take 3x squared y squared, and let's multiply it by 2xy squared plus 8x squared y minus 3. All right, so to do this, you're going to distribute. Okay, so you're going to take this 3x squared and multiply it by 2xy squared. And you're going to distribute it here. And then finally, you're going to distribute it here. All right, so then 3 times 2, well, that gets me 6. X squared times x gets me x cubed. And y squared times y squared gets me y to the 4th. Now let's move to the next multiplication, next product. 3 times 8 gets me 24. X squared times x squared gets me x to the 4th. And then y squared times y gets me y cubed. And these are not like terms because it's x cubed y to the 4th. This is x to the 4th y cubed. So these are not like terms. Then finally, minus just 3 times 3 gives me 9, x squared, y squared. And this kind of brings our lecture on polynomials to a conclusion. And you'll get a chance to practice this in the assignments. And if you have any questions, let me know.